A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. We learned about alkanes, alkenes and alkynes, right? Here we have condensed formula and the molecular formula of some alkanes. What are the compounds? First one CH4, second one CH3, that means C2H6, third one CH3, that is C3H8, fourth one CH3, that is C4H10, the fifth one CH3, that means C5H12. Then analyze their molecular formulas. How many carbon and hydrogen atoms differ between adjacent alkanes? One carbon atom and two hydrogen atom, right? Then what is the difference between the molecular formula of any two successive alkanes? CH2, right? Then take the last two compounds C4H10 and C5H12. What is the difference between that two molecular formula? CH2, right? If we add CH2 with C4H10, we get C5H12. In these compounds, what is the relationship between number of carbon atom and hydrogen atoms? Take last alkane C5H12, right? There are 5 carbon atoms and 12 hydrogen atoms. The number of carbon atom is 5. Then multiple 2 with that 5, we get 10, right? Then add 2 with 10, we get 12. That is the number of hydrogen atom. So can you deduce a formula that indicating the relation between carbon and hydrogen atoms? Yes, CnH2n+2, where n is the number of carbon atoms. Clear? Then this series have a common name, that is called homologous series. So what are the features of homologous series? Let's see. The members can be represented by a common formula. The common formula of alkanes is CnH2n+2. Then in homologous series, the successive members differ by a CH2 group. Then in homologous series, the members show similarity in chemical properties, but there is a difference in their physical properties. Then let's take some alkenes. First one C2H4, CH2 double bond CH2. Then second one CH3 single bond CH double bond CH2, C3H6. Then third one CH3 single bond CH double bond CH single bond CH3, that is C4H8. Series of alkenes, right? Then what is the difference in molecular formula between two successive members here? CH2, right? Then what is the relationship between carbon atom and hydrogen atom? Take last alkene, C4H8. There are 4 carbon atoms and 8 hydrogen atoms, right? How we get 8? When we multiply 4 with 2, we get 8. That means when we multiply 2 with the number of carbon atoms, we get the number of hydrogen atoms. So, can you deduce the general equation for alkenes? Yes, CnH2n. The series of alkenes are also a homologous series. Then, let's take some alkynes. First one, CH triple bond CH, that is C2H2. Then CH3 single bond C triple bond C H, C3H4. Then next compound CH3 single bond C triple bond C single bond CH3, C4H6. Then last one CH3 single bond C triple bond C single bond CH2 single bond CH3, C5H8. Then in this series of alkynes, what is the difference in molecular formula between 2 successive members? CH2, right? This is also a homologous series. Then, what is the relationship between carbon atom and hydrogen atom? Take last alkyne, C5H8, right? How we get 8? The number of carbon atom is 5. Then multiply 5 with 2, we get 10. Then subtract 2 from 10, we get 8. So this is the number of hydrogen atom. Now can you deduce a general equation for alkynes? Yes, CnH2n minus 2. So, what was our classification of hydrocarbons? Hydrocarbons can be classified into 3: alkanes, alkenes, alkynes. The general equation for alkane is CnH2n plus 2. For alkene, CnH2n. For alkyne, CnH2n minus 2. Don't you remember the naming of elements? Yes, in the similar way, we can name hydrocarbons. Some rules have been formulated for the naming of organic compounds. That rules are formulated by IUPAC. What is IUPAC? International Union of Pure and Applied Chemistry. It is an international organization that strives to carry forward the new trends in the field of chemical science happening worldwide and thereby contribute to the application of chemistry for the service of mankind. IUPAC takes the lead role in naming the elements and organic compounds. So, IUPAC has put forward some rules for naming the hydrocarbons. Do you know what are they? the two main points that are to be considered while naming organic compounds are the nature of bond between carbon atoms and the number of carbon atoms. Clear? Then IUPAC adopted certain word roots for the number of carbon atoms. They are, if the compound contains only one carbon atom, then use the word root meth. Then for 2 carbon atom, the word root is eth. For 3 carbon atom, prop. 4 carbon atom, but. For 5 carbon atom, pent. For 6 carbon atom, hex. For 7 carbon atom, hept. For 8 carbon atom, oct. For 9 carbon atom, none. And for 10 carbon atom, the word root is dec. So now you know the word root corresponding to number of carbon atoms, right? Now we are going to name some alkanes. Are you ready? So let's see how saturated hydrocarbons are named. Here are 3 compounds and their IUPAC names are also given. What is the first compound? CH4, right? The name is methane. Then second compound C2H6. The name of that compound is ethane. And the third one is C3H8. 3 carbon atom name propane. What is so special in their names? How are the names derived from the word roots? Yes, a common suffix is added to their word roots. What is that suffix? Ane, A-N-E. So, ane is added to the word root as suffix. Now, can you tell me how we can give IUPAC names to alkanes? Yes, by adding ane with their word root. The word root corresponds to number of carbon atoms. Take first compound CH4. 1 carbon atom. So, the word root is meth. Then add suffix ane. Meth plus ane. We get methane. Then second compound. There are 2 carbon atoms. So, the word root is eth. Then add suffix ane. Eth plus ane. We get ethane. So, can you tell me which is the next alkane? The alkane with 3 carbon atoms, right? The word root is prop plus ane, propane. Then next one, butane. Next one, pentane. Then the alkane with the 6 carbon atom, hexane. Then heptane. Then octane. Then nonane. Then the hydrocarbon with 10 carbon atoms, decane. So, this is the way for giving IUPAC names to alkanes. First, we have to write the word root, then add suffix ane. We get alkane. Are you clear? Okay. Now we know how to give IUPAC names to alkanes. Then there are branched alkanes or branched saturated hydrocarbons. How we will give IUPAC names to that compound? We will study later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.